So in this lesson, we're going to go into what I think is one of the more complicated ideas in computer science, and that is, what is an interface? If you try to answer this on your own, like let's just say you Googled what is an interface, you get some answers, but they wouldn't necessarily help you with the homework. But let's try that. Let's dive into that idea. So we do see Java coming up here. Yeah, what is an interface? Java tutorial. So that's good. We'll come back to that. That's actually probably the thing that's most useful for you in the coming weeks. But an interface in computing is actually a much more general idea than an interface in Java. Let's try the first sentence of the Wikipedia article. So in computing, an interface is a shared boundary across which two or more separate components of a computer system exchange information. A shared boundary across which two or more separate components of a computer system exchange information. I think this idea of a boundary is helpful when thinking about interfaces in general. And this next sentence, I think, shows you how general this idea is. So this exchange across that shared boundary can be between software, hardware, peripheral devices like a keyboard or your mouse, humans like me, or some combination of these. So if I'm using the computer through a mouse, that's the interface, right? The mouse is the interface to the computer. The monitor, though, in which I'm seeing information that's stored on my computer or in memory, being displayed as rays of light that go into my eyes, that's part of the interface as well. That's the interface between the human and the computer. So obviously, it's a very general idea, but when you're programming, usually when we say interface, we're talking about how one part of our program interfaces with some other part of our program. Anytime there are two parts to a program and they're talking, they're sharing some boundary across which some information is flowing. So I think that's the key idea to start understanding what an interface is in Java. Now, even in Java, the word interface gets used in at least two different ways. So let's look at the two different ways that the word interface gets used. So number one, you're going to see it in the term API, which is Application Programming Interface. Maybe you've already seen this word, or this acronym, but the I in it does stand for interface. So the way I think you might have come across it before is in looking for documentation for some Java class. So a common Google search when you're a programmer might be something like, what is the ArrayDec API? And when you search for ArrayDec API, usually Google or whatever your search engine is smart enough to come up with the documentation. And indeed, you can even see the word API that appears right here in the URL, because what a document for some class does is tells you what its interface is. And if we remember, we're talking about interface in the sense of it's how one part of your program might communicate with another part of your program. So in this case, what's being documented on this page is how parts of your code could interface with an ArrayDec object. And that interface is essentially, at least in Java, it's a collection of all the methods you can call on some ArrayDec. So we'll look into a couple of these in just a moment, and this ArrayDec is going to come up in your next homework. But just to test that, let's throw together a quick main method here. Public static void main string args. And let's make a new ArrayDec. So we'll say ArrayDec A equals new ArrayDec. Now it won't work at first, right? Because we need to import it. If you mouse over it, it will let us import that automatically. So now we have an ArrayDec. We have, at least after this line, after line 14 runs, there is now an ArrayDec in Java's memory. And could do other stuff to it, but the stuff you can do to it is defined by its interface. It's documented on this page. So we could add something to it. We could add first. We could clear and remove all the elements. We could clone it, whatever. There's a lot of stuff that we can do with an ArrayDeck. But my point is that all of that stuff taken together is something that programmers call its API, its Application Programming Interface. So that's one definition of what an interface is all the stuff you can do to, in this case, an ArrayDeck. So that's definition number one. But Java, and I'll admit I think this is a little bit confusing, actually uses the word interface in another, slightly more technical way, in that an interface is something that you can create. I'll make one right here for you. You can say public interface, example interface. And notice, no errors there. That's because Java knows what this means. It knows how to let me define an interface. And so that idea, that sort of, I'm going to call it a Java-specific interface, even though this does come up in other programming languages, not just Java. This is a Java class, so of course we're going to talk about interfaces as they're defined in the Java programming language. So I would define this first definition of interface as all the methods you can call on some object of some class. But then there's this other notion of an interface that's related to this one, but has a technical enough meaning inside of Java that I think you should think of them as slightly different but related things. So this Java-specific interface, you can sort of see how this is a little bit confusing, because as I said, this is the API docs for ArrayDeck. So this is defining what the interface for an ArrayDeck is, but then it also says right here, all implemented interfaces. So an ArrayDeck implements serializable, clonable, iterable, collection, deck, and queue. And when you see this in some documentation for some class, what it means is if ArrayDeck implements, let's say, the collection interface, it means that an ArrayDeck is guaranteed to have all of the methods that are defined by the collection interface. So I'll say that one more time, because that's the definition here. If an ArrayDeck implements the collection interface, it means that an ArrayDeck has all of the methods defined by the collection interface. Let's dive into that a little bit more. So I'll open up collection here in a second tab. And we see that collection has the following methods: add all, clear, contains all, equals. So if an ArrayDeck implements the collection interface, it means that ArrayDeck has, let's say, a clear method. And we can test that. So we have an ArrayDeck right here. We now know, because we read the API for ArrayDeck, we now know that ArrayDeck implements a Java-specific interface called collection, which means that we can say something like a.clear, and Java's perfectly fine with that, because clear is a method you can call on an ArrayDeck. So I'll try to give a sort of definition to this Java-specific notion of an interface. This is a programmer-defined set of methods that classes can implement. So a set of methods, in this case in collection, was implemented by whoever wrote ArrayDeck. So somebody sat down to write ArrayDeck, and here's probably what it was like. So I'm going to get rid of this And let's just say, let's say we're making our own array deck. I'm going to say public class my array deck. And then if I want it to be a collection, to implement collection, I would say implements collection. And then we should immediately get some errors. Well, first, it doesn't know what collection is, so let's import that. And then it's happy about collection, but we're getting some errors over here. So now Java is complaining about myArrayDeck because I've declared this implements a collection. It has the collection interface. But in fact, I haven't implemented any of those methods. And so if I mouse over this red underline, Java's helpfully telling me, hey, there's a whole bunch of methods here that you have to implement. So it says here the type must implement the inherited abstract method collection.size. So okay, well let's do that. Let's add the unimplemented methods. Actually added a bunch of them, right? So now Java's happy because myArrayDeck has a method for size. Not a very useful one, just returns 0. But you know what? Java doesn't care if it does the right thing, just cares if you have the method. Now myArrayDeck does implement collection because it has a size method, it has an isEmpty method, it has a contains method, has an iterator method, toArray, add, contains all, remove, blah, 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 and finally clear, right? So I'm going to get rid of all that now, but the point is that in Java, this sort of Java-specific idea of an interface is that any class can say it implements some interface, and Java will make sure that it does at least have the methods that that interface says that it should have. So I'll do one more demo of this idea and how it comes up in Java. So let me get rid of this, and I'll say public interface. I'll say, I'm going to call this one nameable, meaning that something, my intention here with this is that if some class implements nameable, then it must have a name method that returns a string. So I'll say public string name. And in fact, don't need to say public. In an interface, it's assumed that all methods are public. So I now have an interface, but interfaces don't do much until there's a class that tries to implement them. So once again, I'll say, I'll define a class here, and let's call it cat. So I'll say that cats have names. So if I want a cat to be a nameable, I would say implements nameable. And then we get the same red underline as before when I try to implement collection. If I mouse over it, it says cat must implemented the inherited abstract method nameable name. And it gives me the nice convenience of allowing me to add that unimplemented method. So here we have a public string name. It's returning null. Not really a very useful name, but like I said, Java doesn't complain if the code is wrong. It just complains if you don't have the method at all. So now a cat is a nameable. I can have some other thing like a dog, I guess, or let's do something totally different like a country. Countries also have names. They're not really very similar to cats, except in that they're both nameable things. And that one commonality between cats and countries is something that I've captured in this interface called nameable. What that lets me do now that I have cats and countries that are nameable, is just for example, I could have an array deck of nameable objects. And that array deck could have cats and countries in it, or cats and dogs and humans and countries and whatever. As long as the kinds of things in that array are nameable, then Java's fine with that. And as long as I only try to do things that involve calling .name on the stuff in here, it really doesn't matter if it's a cat or a country. I can call .name on either one, treat that name as a string, do whatever calculation I want on it. So by declaring this sort of Java-specific interface, a programmer-defined set of methods that classes can implement, Java will make sure that anything that does implement some interface has those methods. So coming back, once again, to the top, in some class, for some class, you will often have an API page, API documentation page that documents the full interface for that class. I'm using the word interface in that generic idea of, this is the boundary across which one part of your code might try to talk to an array deck. But then in Java, we talk about classes having interfaces sometimes in a more specific way. We say that they implement an interface, which means they have some collection of methods. And you can implement many interfaces, meaning that an array deck will have some subset of its methods that come from serializable, some that involve clonable, some that involve iterable, some that involve collection, some that involve deck, some that involve queue, and so on. And then maybe some additional ones that are just part of array deck, and they are not necessarily part of these implemented interfaces. Computer science, unfortunately, is full of examples of this where the same word gets used in two slightly different ways, and it absolutely can cause some confusion, especially when those two ways are related to each other. That said, if you don't fully get it, you don't fully get the distinction between these two things, that's okay. It doesn't matter. As long as you understand that you can create interfaces in code, and then that any classes that implement them are held accountable by Java. And other programmers can create interfaces, and then if you implement them in your classes will be held accountable by Java. It will just make sure that they have certain methods. That's it. That's the Java idea behind what an interface is. So I remember when I was first learning Java, and sometimes I would learn about these concepts like interfaces, and I would say to myself, yeah, I think I get it, but why should I care? And that idea of I get it, but why should I care left me feeling like maybe I actually didn't get it, because why are my professors bothering to tell me about interfaces, and why do programmers care about them so much if they're not all that useful or interesting? So I've defined interfaces so far, but we haven't really used them in a way that maybe suggests why they might be useful. So I'll try to do that now. We'll try to write a program that uses interfaces in a way that shows how they could be useful. So let's say we're making a game, all right? I'm just going to start writing some code as if we're making a game. So might start by making a class called game, and maybe games have multiple levels, but I don't know yet. So I'm just gonna do a public static void main. I'll copy my public static void main from my other file. We'll go into game, and maybe games have a list of levels, and you go through them in order. So I'll say something like, okay, games have a private list of levels called levels. And then let's go ahead and make sure we import what needs to be imported here. We can import list. Level, though, can't import that. We got to make that because that's part of our game. So let's make a new interface. Maybe levels should be an interface. All right. And now, you might be asking yourself, well, why? Why should they be an interface? Why shouldn't they be a class? That's totally valid questions right now, but we'll come back to that. Let's just say, let's make levels an interface. Level will be an interface, and our game's levels will be a list of level. So what we might do is, let's just say when we create a game, we might initialize those levels. And then when we play a game, maybe we just go through each level in order and play it. So let's make a list. Let's iterate over our list of levels. I'll say level L in levels, and we'll say L.play, because playing a game involves going through each level and playing that level. And now we end up with an issue, because we called play on a level, but there is no play method declared in that interface. So let's declare one. Let's say that it's void play. So anything that's a level will have a play method. So if we do that, then all the errors go away. Now, what I think is really cool here, what I think illustrates something about why interfaces are cool, is that we're starting to think about the logic for our game, and we haven't yet had to implement any levels. We haven't even said what kind of game it is. And yet we have done some productive work already by saying that a game has a list of levels and that you can play a game and that act of playing a game is going to have Java loop through all the levels and play them, or allow you to play them. So even without defining what the game type is or what the levels will be, we've been able to say what this high-level logic is. Enough that we could say something like game g equals new game, and we could say g.play, and at least all compiles. So we're able to make progress at this high level without actually having to make anything in particular for a level. We could now, that would be a good next step, right? Is we could now say something like, let's say level 1 implements level, and then we get this predictable error. Let's add unimplemented methods. Let's just say system.out.println and we'll say level 1. And maybe we would, maybe it's a text-based game, and at this point maybe we would say something. Let's say something like you find yourself in the woods. Do you want to go north or south? Something like that. And then let's say level 2 is when you go, I don't know, when you get out of the woods. Let's say you find yourself at a house. So let's make a class called level 2. And I'm actually just going to copy over a lot of stuff from level 1. Say implements level. And then the play method for level 2, you could say something like you find yourself at a house. Do you want to go inside? Something like that. Now, over here in game, we can say that levels is going to be a new list of level. And then we can say levels.add. A new level 1 and a new level 2. We have to say that this is an array list. We have to pick the type of list. Let's import it. Now, just as a side note here, this is yet another example of using an interface. I've said that levels is a list. but I've declared it as a list, but then when I constructed levels, I said I want an array list. And if we look at the API for array list, if we look at the docs, we see that array list implements serializable, clonable, iterable, collection, and list. Look at that. Array list implements list, which means that an array list has what methods? Let's see. Let's find out. Let's go to the documentation for the list interface, and we see that it has add, add all, add, clear, contains all, equals, etc. So, which is why I can call add right here on this array list, because array list is a list. Additionally, I don't have to make this an array list. I can make this anything that implements list. So what other things might that be? Well, here I am back on interface list, the docs, and we can see that all known implementing classes are abstract list, abstract sequential list, array list, that's the one I'm using, attribute list, copy on write array list, linked list, role list, etc., stack, vector. So if I wanted to, if I decided later on that an array list is not the correct type for levels, I could switch it, let's say, to a linked list, and then import that. And Java's happy. It doesn't care if it's an array list or a linked list, because at the top level, I've declared that levels, all it is it needs to be something that has the interface of a list. And array list and linked list both implement the list interface. So that means all of my logic that assumes it's a list, like calling .add on it, should work for anything that implements list. And since Java makes sure that something that implements list is going to have certain methods like add, it's safe to write your code with .add as long as you have specified that the thing you're .adding is a list. All right, so without further ado, let's just see what happens when we play. So play should call, so calling .play should call this method, which will loop over all the levels and call .play on them. Now, right now, they're not really set up. They're not really implemented as good levels with interactivity. They're just going to print out some stuff, but that's okay for now because we're not really making a game. I'm just trying to show you a little bit about why you might find it useful to define something as an interface. So let's run this. Yeah, there we go. So we find ourselves in the woods. Do we want to go north or south? And then we go straight to level 2 and we find ourselves at a house. Do we want to go inside? It looped over all of our levels, and because level 1 and level 2 both implement level, they both have a .play, so we can write something very simple like this, a play function that doesn't really care if it's a level 1 or a level 2 or a level 10 or a secret bonus level. It just cares that it's a level, because all play really needs to do is call .play on the levels. And because it needs to do so little, it needs to assume very little. It just needs to assume that it's a level, which means that it's assuming that it's something that implements level. I hope that this clarified it a little, or at least gave you more questions that you can ask. As always, feel free to ask me questions. I don't mind. I do remember learning this stuff for the first time, and I remember it being a little bit confusing for me as well. So if it's a little bit confusing for you, that's okay.